Welcome to the world of natural language processing. It is the field where we teach computers to understand and process human language using artificial intelligence. Consider it as giving machines the ability to comprehend and respond to us in our own language. Natural language processing, or NLP, is a branch of artificial intelligence that empowers computers to understand, interpret, and manipulate human language in a meaningful manner. It serves as a bridge, connecting human communication with computer understanding. NLP enables computers to understand and process human speech and text. It combines linguistics, computer science, and artificial intelligence. And it aims to make human-computer interaction more natural and intuitive, powering applications from translation to sentiment analysis. Let's explore the key components of natural language processing. First, text processing, which transforms raw text into structured data that computers can analyze. This involves tokenization, lemmatization, stop word removal, and part-of-speech tagging. Next, syntactic analysis. It analyzes sentence structure and grammatical relationships, and involves grammar checking, dependency parsing, constituency parsing, and understanding phrase structure. After that, semantic analysis. It extracts meaning and context from text, covering word sense disambiguation, named entity recognition, semantic role labeling, and relationship extraction. Finally, machine learning applies AI algorithms to process and understand language, utilizing word embeddings, deep learning models, language models, and transfer learning. Let's delve into the essential text pre-processing steps in natural language processing. Step 1. Text cleaning. We remove special characters, uniform resource locators, and unwanted symbols. Step 2. Case normalization. Convert text to lowercase for consistency. Step 3. Stop words removal. Filter out common words like the, is, and at. Step 4. Tokenization. Split text into individual words or tokens. Step 5. Normalization. Convert words to their base or root form. Here's an example. We will import Natural Language Toolkit, tokenize stop words in WordNet Lemmatizer. We take a sample text, clean the text by lowercasing it and removing special characters. Then we tokenize the sentence. After that, we remove stop words. And in the final step, we lemmatize the words. Let's take a closer look at tokenization and lemmatization. Tokenization splits text into meaningful units, such as words, numbers, or punctuation marks. It's the first step in text processing. For example, the input sentence "the cat is sleeping" becomes "the cat is sleeping" after tokenization. Lemmatization reduces words to their base form, known as the lemma, using vocabulary and morphological analysis, preserving the word's meaning and context. For example, running becomes run, better becomes good, and was becomes be. Parts of speech tagging, also known as POS tagging, identifies the grammatical parts of speech for each word in a text, providing crucial linguistic information for natural language processing tasks. Here are some common tags: NN for nouns such as cat or book, VB for verb such as run or write, JJ for adjective such as happy or blue, RB for adverb such as quickly or very, and IN for preposition such as in, on, or at. Here is an example. We import Natural Language Toolkit and tokenize. For the sample text, "the quick brown fox jumps." After tokenizing and tagging, the output is the with tag determinant, quick with tag adjective, brown with tag adjective, fox with tag noun, and jumps with tag verb. Let's explore named entity recognition, or NER. NER identifies and categorizes named entities in text, such as people, organizations, locations, dates, and monetary values. Here are some common entity types. Person, which refers to names of people. Organization or ORG, which refers to organizations. Location, which refers to locations. date which refers to dates and times, and money which refers to monetary values. Here is an example text with NER. John Smith, which is a person, works at Google, which is an organization in Mountain View, California, which is a location. On January 15, 2024, which is a date, he received a bonus of $5,000, which is money. NER has many applications, including information extraction, question answering, document classification, knowledge graph construction, and search engine optimization. Let's learn about sentiment analysis. Sentiment analysis is the process of determining the emotional tone behind a series of words, used to gain an understanding of attitudes, opinions, and emotions expressed in text. For example, the sentence, "This product exceeded my expectations," has a positive sentiment with a score of 0.89. The sentence, "The service was okay, nothing special," has a neutral sentiment with a score of 0.12. The sentence, "I'm very disappointed with the quality," has a negative sentiment with a score of -0.75. Here is a Python example. We import pipeline from transformers. We initialize a sentiment analyzer. For the example text, "This product exceeded my expectations," the output is label positive and score of 0.89. Let's talk about word embeddings. Word embeddings are numerical representations of words in a high-dimensional space. They capture semantic relationships between words by converting them into dense vectors where similar words are closer together. For example, the word king could be represented by the vector containing 0.50, -0.23, 0.78, 0.12, and so on. Similarly, the word queen could be represented by the vector containing 0.48, -0.21, 0.76, 0.15, and so on. In vector space, the relationship between king and queen is similar to the relationship between man and woman. Let's explore some applications of natural language processing. First, search engines which understand user queries and find relevant results through semantic search, like Google's semantic search understanding. Next, chatbots which provide automated conversation systems for customer service and support. For example, customer service virtual assistants. Then, translation which provides automatic translation between different languages while preserving meaning. For example, Google Translate and DeepL. Also, text analytics which helps in extracting insights and patterns from large text datasets. For example, social media sentiment analysis. Content creation provides automated generation of articles, summaries, and reports. For example, AI-powered content writing tools. Finally, information extraction automatically extracts structured information from text, like resume parsing systems. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.